classification of the elements. So what are the classification of the elements? 5 classifications we are having. First one is active and passive elements, and second bilateral and unilateral elements, and third is linear and non-linear. Fourth one is time variant and time invariant, and fifth is lumped and distributed elements. So we will go for one by one. So what is active elements and what is meant by passive elements? So these are very important. So active and passive elements. An active elements means an elements which are capable of delivering the energy. An elements which are capable of delivering the energy is called the active elements. And elements which are not capable of delivering the energy is called the passive elements. The best example for the active elements is voltage source and current source. So the best example for the passive elements is R, L, C. What is R? R is a resistance, L is a inductance, C is a capacitance. Resistance is a property of a resistor, inductance is a property of a inductor, capacitance is a property of a capacitor. So in this active elements, we can go for the independent sources, and again it is a dependent sources. Independent and dependent sources. In this independent, we are having ideal and practical. Ideal and practical. So ideal voltage source, how many sources we are having? Voltage source and current source, 2 sources we are having. That is ideal voltage source and ideal current source. Ideal current source. So coming to the practical also, practical voltage source, this is voltage source, and the second one is practical current source. In this dependent sources, we are having a 4 types, that is voltage dependent voltage source, and the second one is voltage dependent current source. Here V is the voltage, D is called the dependent, and the I is called the current, and S is called the source. Here I am writing in a shortcut way. Voltage dependent current source, current dependent current source, and current dependent voltage source. See here, we are having a 5 classifications. What are those classifications? Active and passive, linear, non-linear, lumped, distributed, time variant, time invariant, bilateral and unilateral. Again, in this active and passive elements, we are having in this active elements, independent sources and dependent sources are present. In this independent, again we divided into ideal and practical, and ideal voltage source we are having, ideal current source is also having, practical voltage source and practical current source. In this dependent, we are having a voltage dependent voltage source and voltage dependent current source, current dependent current source, and current dependent voltage source. And now, so what is the definition of a active elements? So active elements means and elements which are capable of delivering the energy, and elements which are capable of delivering the energy to the external elements, is active elements, is called active elements. Examples of active elements is voltage source and current source. And what is meant by passive elements? So passive elements which are not capable of delivering the energy, which are not capable of delivering the energy to the external elements. The examples of passive elements are R, L, C, resistance, inductance and capacitance. So this is about the first classification. Now what is the second classification? Second classification is bilateral and unilateral elements. Bilateral and unilateral elements. So what is meant by bilateral element? So what is meant by element? Element which consisting of two terminals. Bilateral elements means if I am taking a resistor whose value is 1 ohm, if I am sending the current in this direction, now what is the resistance value? Let us say this first terminal is A and the second terminal is B, or AB is equal to 1 ohm. Suppose if I am sending the current in an opposite direction from B to A, is there any change in the resistance value? There is no change. Then RBA is also 1 ohm. The resistance offered by the element is same, even though for different directions of current, that is called the bilateral element. When RAB is equal to RBA, we can call it as a bilateral element. So bilateral element. If it is not equal, so then we can say that it is a unilateral element. Okay. So we understood that for a resistor, even if you pass the current in this direction or opposite direction, the element value is fixed or the element value does not change, then we can call it as a bilateral element. So the examples for the bilateral element is R, L, C, resistance, inductance and capacitance. So we will discuss one by one what is the inductance and what is the capacitance and what is the property of a resistance. So if you take a diode, so PN junction diode, so this is called the depletion layer. P is given to positive terminal of the battery and N is given to the negative terminal of the battery. In a P, the majority carriers are holes. If you go for the N, majority carriers are electrons. When the P is given to positive terminal of the battery and N is given to the negative terminal of the battery, what will happen? Holes having a positive charges and the electrons having a negative charges. Electrons are repelled by the negative terminal of the battery. Holes are repelled by the positive terminal of the battery. So suppose if a wall is there, so here from this opposite force also you can push in this direction, what will happen? This junction will be breaks down, so then the conduction will be starts, it acts as a short circuit. So when a resistance value is equal to 0, in an ideal case resistance value is equal to 0 when the diode is forward biased. Suppose if the supply is reversed now, P is given to the negative terminal of the battery and N is given to the positive terminal of the battery. The majority carriers in the N are the electrons here and the majority carriers in P are holes, and holes are attracted by the negative terminal of the battery and electrons are attracted by the positive terminal of the battery. Here wall is there, holes are moving in this direction and electrons are moving in this direction. What will happen? The depletion layer will be increases, then there is no current. Ideally say there is no current, the resistance is infinity, then the diode is reverse biased. See here, so the current is flowing in this direction. In the second case, the current flow will be in this direction in the first case. So here the current is in this direction. In the second case, the current is opposite direction, but the resistance offered by the element is not same. So during forward biased, the resistance will be 0. During reverse biased, the resistance value is infinity. So the diode is the best example for the unilateral element. So the diode is the best example for the unilateral element. Okay, so bilateral elements are R, L, C, and unilateral elements is the best example is diode. And what is the third classification? And the linear and non-linear elements. Linear and non-linear elements. Linear and non-linear elements. So what is in by linear element? If you take a x-axis, y-axis and x-axis relationship, a straight line which is passes through the origin, then we can say that it is a linear element. An element's characteristics are increasing linearly, or a straight line passes through the origin, then we can say that it is a linear elements. The best example for the linear elements are R, L, C only. And if you take a diode characteristics, during the forward biased condition, so the characteristics is like this, and V versus I, and during the negative reverse biased condition, so this is the curve. So here we can say that it is a linear. An element which obeys Ohm's law is called the linear element. An element which obeys Ohm's law is called the linear element. We will discuss what is the Ohm's law. So, or a straight line, the element's characteristics are a straight line which passes through the origin. So in this direction also, we have to take in a third quadrant also, a straight line passes through the origin, then we can say that it is a linear element. But by seeing this curve, we can tell that it is not a linear, it is a non-linear. But the example for the non-linear element, is diode. See here, the previously, diode is the best example for the unilateral element, and R, L, C example for the bilateral element. And here also same thing, linear elements are R, L, C, and non-linear elements are, the example is diode. And coming to the fourth classification, what is the fourth classification? Time variant and time invariant, or time variant elements. So an element's values or instantaneous values or changes with respect to time, then we can call it as a time variant. As I am taking one signal, this is a sine wave. Yes, let us say this is V versus omega t. So sine 0 is 0, and this is 90 degrees, sine 90 is maximum, sine 180 is 0, sine 270 is a negative maximum here, minus V maximum here, sine 360 is 0. See, at different values of the time period, the magnitude value will be changes, the amplitude value will be changes here, see here, it will be changes. As the time progresses, the amplitude or magnitude value will be changes. So that's why it is called the time variant element. The best example is AC sources, that is AC voltage source and AC current source. AC current source. If you go for the time invariant, as the time progresses, there is no change in the magnitude. The best example, as the time progresses, there is no change in the magnitude of the current. So DC current source. DC current source or DC current value or DC voltage value. So DC voltage value or DC voltage are constant. DC voltage is constant. So coming to the last classification, lumped and distributed elements. Lumped and distributed elements. So what is meant by lumped element and what is meant by distributed elements? And elements which are physically seen, then the element we can say that it is a lumped element. Distributed elements means which are not physically seen or which are not physically separable, then we can call it as a distributed elements. Suppose if you take a resistor, carbon resistor, and the carbon resistor consisting of a color coding, carbon resistance consisting of a color coding like this, and by seeing this color coding, we can tell the what is the value of the resistance. Let us say it is 1 kilo ohm or 2 kilo ohm or 3 kilo ohm. But if you see the conductor, so which is made up of copper, it is a straight wire, and in a poles also we are having a conductor. This one is a phase and this one is neutral. By seeing this wire, we can't tell the resistance value. Physically it is not separable, but it is physically separable. By seeing this carbon resistor and by seeing this resistor, we can tell the value of the resistance. So then this element is called the lumped element. And but here in this, if you go for the distribution lines, this is called the distribution line. So from the pole only 2 wires are coming to our electrical meter, and this is called the distribution line. And if you take a copper wire also, which is not physically seen or separable, then this type of element is called the distributed elements. Okay, so once again I am revising from the basics point. So what is the meaning of a circuit and what is the meaning of a network? An interconnection of an elements. What is an element? Element is a two-terminal device. An element is a two-terminal device. If you take a resistor, resistor is a two-terminal device. An interconnection of an elements is called the network. So a network which should consisting of at least one closed path is called the circuit. At least one closed path is called the circuit.